All right, welcome back to Mr. PL's with Algebra 2. This is Unit 3, Topic 1, SLT number 2, Video A. We're going to do this SLT in 2 videos. We're going to be talking about how to find the height of various points of a Ferris wheel, but we're going to be using it with time. So we're doing it a little bit differently, and we're going to be coming up with a formula that could be used every single time, because we don't want to be making a table like this or making a diagram and then making a table every single time we do this question. So the whole point of this is to figure out, well, what algorithm can we figure out that does basically the same thing as what we're doing, only I can just plug that into my calculator and get an answer instead of doing all this work to figure out the one answer. A playground merry-go-round has a radius of 8 feet and a center that's 15 feet high. Find the distance at each given point. So this is very much a warm-up of what we had done before. So we know that A is 15 feet high and so is E, because point A is the same height as the center of the Ferris wheel. So what I need to know now is, what's the height of B? Well, I don't know if this is 8. So 8 is the distance of, in fact, I know it's not 8, because 8 is the distance all the way to A. So that's not a known amount. But what I can do is figure out what this degree is, and I can figure out that this length, which is the hypotenuse, is 8, because the radius is 8 going in any direction. 1, 2, 3, 4, 5, 6, 7, 8. So now if we have 8 sections, there's 360 degrees in a circle, and if you divide that by 8, then you're going to get 45 degrees. So we know sine of 45 degrees is equal to x right here, which is the height of B, over 8. So then I can do 8, come on, calculator. Let's try that again. So 8 times sine of 45. Remember, check to make sure that you're in degrees and not radians. I'm getting 5.66. Yep, 5.66. If I round it to the nearest hundredth. Now, if I add that to the 15, 5.66 plus the 15 gives me a height of 20.66. 20.66. Now, I know height of D is going to be exactly the same, because these two are the same height. Now, if this height is 5.66, and I know this center height is 15, to find H, I'm just going to do the opposite. Instead of adding, I'm going to subtract 5.66, and that's going to give me 9.34. 9.34 goes here, and 9.34 goes here, because F and H have the exact same height, which only leaves me with C and G, which I could have done first, but I decided to do them last. The center height is 15. You add another 8. That's pretty easy. Simple math. All you have to do is add those two together up, and you get 23 for C. And 15 minus 8 gives you a difference of 7. So there's your lowest point, and there's your highest point. There's no reason to do sine and cosine, because you know what this sprocket's length is. You don't need to calculate it. All right, so getting into this video. So it starts off with doing this sort of exploration of how to figure out this formula. And it tells you that if we're using basically the same question as the warm-up, if it takes 12 seconds to go one complete rotation, well, first of all, 360 divided by 12 gives us 30 degrees per rotation. So after 1 second, you've gone 30 degrees, then 60 degrees, then 90 degrees, then 120, 150, and so forth. 180, 210, and then you can keep going, and then you're going to end up getting to 360, which is a full circle. 240, 270, 300, 330, 360, and you should not be shocked that the height of 360 degrees is going to be the exact same as 0 degrees. And the next one's going to be 390, and that'll have the exact same answer as 30 degrees. And then the next one will be 420, which will have the same height as 60 degrees. Now, it's a pattern, so this will just repeat. The whole sequence will repeat all over again. So in order to do that calculation, so I'm going to do the radius times, and this is the formula that we end up using. This is the whole point of this. So 8 times sine of 30. And that'll give you your distance from the wall. So if you add your center height, that'll give you your distance from the wall. So 8 times sine of 30, end parenthesis, add 15, and you get 19 exactly. Now, you're not going to get a whole number every single time. This will all stay the same, but the only thing that you're going to change is the 60 on the inside. So this is the formula that we use. So you multiply the radius times sine of theta, which is the amount of degrees that it's rotated around the circle, and you add the center height, and you've got yourself. And that's pretty much what we've been doing in all the warm-ups up to this point. So it kind of makes sense that this works. 8 times sine of 60 and parentheses add 15. Now, if I had more time, I would go through all of these and show you what they all are, but I'm sure you're pretty much capable of doing that yourself. Just keep changing the degrees. The thetas keep changing to these numbers, and what you'll see is that these numbers will once again repeat. You'll also notice that, like, position, if I go back here, okay, so you'll see like position B is the same as D, so please don't be shocked when you see here, when you see like this one's the same as this one, and this one's the same as this one, and so forth. Because that's not shocking, because actually it would be like these two are the same, and then these two are the same, and then these two are the same. It's because they're like on opposite positions of the circle. Now I know this isn't correct. I know I was just kind of giving you a reference of what it would be like. I'm not saying those exact points that are the same, but that is going to happen. It's going to be a repetition because you're going to the same height twice as you go around the circle. What you'll notice here is that basically they're getting the exact same answer. They both got an answer of 11. You can read the scenario yourself. The reason why they're doing it in different methods is because what he's doing, Mary, what she's doing actually is she's figuring out the height of this position, and she's realizing that this position is also 4. So if this is 4, then this is also 4. And the height of 15 minus 4 gives me this position right here. So that's one way of doing it. Or you could say the height of this position to begin with is using this formula, and that also gives you a height of 11, because this is all negative 4, negative 4 plus 15. Negative 4 plus 15 is the same thing as 15 minus 4. So if you take this height and you subtract 4 from it and go down, you're going to get the exact same answer as if you take negative 4 and add a height of 15 to it. You're going to get the height of this point. What you'll notice is that anytime you're doing sine of a value that's higher than 180, or between 180 and 360, I should say, you're always going to get a negative value, which makes sense because once you've got 180, you're now below where you started. That's the reason why it kind of makes sense. So when you come up with an equation, so you always take the radius like we did in the very beginning, multiply it by the sine of, now the degree. Now the degree would be the amount of time it takes multiplied by theta, which represents the amount of degrees per second. And then you add the center height. And there's your, now if you don't want to use theta, you can say the degrees per second. So t times degrees per second. And that would be the exact same thing. A Ferris wheel has a radius of 35 feet and 42 feet from the center. And determine the model if it takes 30 seconds to complete one rotation. So what do we need to know? We need to know how many degrees is it doing. How many degrees is it doing per second? Let me move myself down. So we do 360 degrees, divide that by 30 seconds. 360, that should be 32, I believe, right? Divided by 30 equals, oh, I'm sorry, 12. I don't know what I was thinking. How many seconds will it take to be apart from the, how many seconds will it take to be the point furthest away from the ground? Well, if it takes 12 seconds to go all the way around, then you know it takes 6 seconds to go halfway around. So if it takes 12 seconds to get to here, and then to get to halfway, that would take 3 seconds. 3, 6, 9, 12. There's the easiest way of doing it. What is the distance from the ground after 10 seconds? Well, 10 seconds would be somewhere around right here. Okay, so we can once again use our formula. So which is radius times sine of t amount of seconds times the degrees per second, which we already said was 12, plus the center height, which was 42. Now you can use a calculator. Put that whole thing in the graphing calculator. It'll tell you the answer. 35 times, in fact, I'm even going to show you what I'm putting in the calculator just to make sure that you're doing it the same as me. You got to make sure you end parentheses so you can see what I've got in there. You got to end parentheses after the 10 times 12 because otherwise you're going to get a different answer. Press enter and you get 72.31 feet high. There you go. 72.